Welcome to ETE 130 Practical Lab 1 with Paul Prey, Zachary Siebel, and Matt Jackson. We were given a circuit to build, which is a monostable multivibrator with a selector switch to put in 2 different times selectively. Now, here's the circuit diagram of the 555 chip. You can see we got the LED coming out of the output. It goes to the resistor, going to ground. You can see here we have the push button circuit coming out of the ground and the trigger, going to a 1K, going to ground and plus 5 volts. And then you have the reset coming over here to pin 8 that's connected to plus 5 volts. That goes through a 10K and a 50K resistor that's connected to the selector switch, which is 1 and 2. And that goes to the threshold and the discharge that come out to a 100 microfarads capacitor that's connected to ground. That is shown here. We have our resistors, 10K and 50K. We got our capacitor and the push button circuit. Now we will test this out. Right now we have selector switch 1 on. So when we press this button, it should take about 1 second for the light to turn off. There we go. Now I will turn on 2 here. Now this one should take roughly 5 seconds, 5.5 seconds. And that worked as well. So on to Zach with the calculations.
So the first thing we did is we calculated the voltage drop on the resistor that goes into the LED. So we just used E equals I times R, which is right here. So we got the 390 volts, or the 390 ohms times the 8.2 milliamps, and we get the 3.226 voltage drop across the resistor. And we simply took the voltage drop, we just took 5 volts minus that, and we got the voltage drop across the LED, which is the 1.774. So then how we figured out how long the LED should turn on, or should take to turn off, we used the RC time constant. So we've got this here, we get the 1.1 seconds for the first resistor when it's just switch 1 that's turned on. But when switch 2 is turned on, we get 5.5 seconds. So we had a problem with our circuit, so our other lab partner is going to show you how we figured that out.
So this is Matthew Jackson, and we had a pretty cool troubleshooting opportunity during this circuit, and we actually weren't, our problem was nothing was working here. So we had our entire circuit wired up, and no matter what switch we used or push buttons, the light wasn't coming on. So we went through the troubleshooting steps and we checked our circuit diagram and found it to be accurate. We pulled the multimeter to find where the issue was on an electrical level. And we actually measured across the positive and ground here. And it was reading 5 volts, so we knew our power supply was working properly. So we ended up checking the ground connector and our 5 volt connector, and our ground connection here was faulty, which was, it wasn't allowing current to flow through the circuit, which was the reason why our LED wouldn't come on. We couldn't get current to flow from 5 volts all the way to ground. So we ended up replacing that connection there, and it was all working properly. I'll hand this back to Pete to wrap it up. And
that about sums it up. We actually also have our Falstad diagram here that we built. You can see we got the 10K and the 50K resistor on switches. So if we take the 10K and close it at switch 1, and we press the button here, then you'll see the light switch takes about 1 second. The timing on here is a little less than actual seconds. It's about half a second, so it takes twice as long real time. And then if we click that off and we click the 50K resistor, and we go here, then you will see that after about So it'd be 10 seconds real time, about 5.5 seconds in the simulation. That light will turn off. Boom. There we go. So that sums up our practical lab for ETE 130.